25% referenced in the context of motor load calculations originates from the National Electrical Code, specifically Table 430.252a. This table is essential for determining the appropriate multipliers when calculating the total full load current of motors, particularly in situations where you have motors with nameplate full load current ratings below 100 amps. It is a crucial reference point for electrical professionals and anyone involved in electrical installations to ensure accurate load calculations and code compliance. The application of this table, and the 25% factor specifically, is tied to the horsepower rating of the motor in question. Motors that are rated at less than 1 horsepower require a specific calculation method, and this is where the 25% multiplier comes into play. The code mandates that for these smaller motors, the calculated load must include an additional 25% of the motor's full load current. This additional percentage accounts for factors such as potential variations in motor performance, starting currents, and to ensure the overall safety and reliability of the electrical system. To further clarify, let's break down why this 25% adder is so important in the context of electrical installations. Firstly, understand that motor loads can fluctuate. Motors, especially smaller ones, might experience variations in their operational demands. The 25% provides a safety margin, ensuring that the circuit is adequately sized to handle these potential fluctuations without overloading. Secondly, the starting current of a motor, also known as the inrush current, can be significantly higher than its running current. This inrush current can be several times higher than the motor's rated full load current, even for a short period. The extra 25% helps accommodate this inrush, preventing nuisance tripping of circuit breakers or other protective devices. Thirdly, the NEC prioritizes safety and reliability in electrical systems. The 25% adder contributes to this goal by ensuring that conductors, overcurrent protection, and other components are adequately sized to handle the demands of the motor under various operating conditions. This reduces the risk of overheating, insulation breakdown, and other potential hazards. Now let's walk through a practical example to illustrate how this works. Suppose you have a small exhaust fan motor rated at 1/4 horsepower, which is less than 1 horsepower. According to its nameplate, the motor draws 4 amps at 120 volts. To calculate the total load, you would take 125% of this 4 amps. That is 4 amps multiplied by 1.25, which equals 5 amps. Therefore, for the purpose of load calculations, you would treat this motor as a 5 amp load, ensuring that the wiring and overcurrent protection are appropriately sized. It is important to note that the 25% adder applies specifically to the calculation of the motor load for the overall circuit sizing. It does not affect the sizing of the motor overload protection, which is calculated separately based on the motor's nameplate full load current and the requirements outlined in Article 430 of the NEC. Article 430 is dedicated to motors, motor circuits, and motor control, and it provides detailed guidance on all aspects of motor installations, from conductor sizing to overload protection and control circuits. When performing motor load calculations, it's always essential to consult the latest edition of the NEC and any applicable local codes or regulations. These codes are regularly updated to reflect advancements in technology, changes in industry practices, and new safety requirements. Failure to comply with these codes can result in hazardous conditions, equipment damage, and legal liabilities. In addition to Table 430.252a, there are other tables and sections within Article 430 that are relevant to motor load calculations. For example, Table 430.248 provides full load current values for single-phase alternating current motors, while Table 430.250 provides similar values for three-phase alternating current motors. These tables can be used to determine the appropriate full load current value for a motor if the nameplate information is not available or is unclear. Furthermore, Section 430.22 outlines the requirements for sizing motor circuit conductors, while Section 430.52 covers the selection of motor branch circuit short circuit and ground fault protective devices. These sections, along with others within Article 430, provide a comprehensive framework for ensuring safe and reliable motor installations. To summarize, the 25% adder in motor load calculations, as derived from Table 430.252 out of the NEC, is a critical factor for ensuring that electrical systems can safely and reliably handle the demands of motors rated less than 1 horsepower. This adder accounts for potential fluctuations in motor performance, starting currents, and contributes to the overall safety and reliability of the electrical system. By understanding and applying these code requirements correctly, electrical professionals can help prevent hazards, protect equipment, and ensure compliance with industry standards. The NEC is not just a set of rules, but a comprehensive guide for ensuring the safe and efficient operation of electrical systems. It is the responsibility of every electrician, electrical engineer, and anyone involved in electrical work to be familiar with the code and to apply it diligently in their work. This includes understanding the nuances of motor load calculations and the importance of factors like the 25% adder for smaller motors. Beyond the specific example of the 25% adder, it is crucial to emphasize the broader principles of electrical load calculation and code compliance. Firstly, accurate load calculations are the foundation of a safe and reliable electrical system. Overestimating or underestimating loads can lead to a variety of problems, including overloaded circuits, nuisance tripping, voltage drops, and even fires. Therefore, it is essential to perform load calculations carefully and thoroughly, using the methods and tables outlined in the NEC. Secondly, understanding the NEC is an ongoing process. The code is updated every 3 years to reflect changes in technology, industry practices, and safety standards. It is the responsibility of electrical professionals to stay up to date with the latest edition of the code and to understand how these changes may affect their work. This may involve attending training courses, reading industry publications, and participating in professional organizations. Thirdly, compliance with the NEC is not just a matter of following rules, but of understanding the underlying principles of electrical safety. The code is based on decades of experience and research, and it is designed to protect people and property from electrical hazards. By understanding the rationale behind the code requirements, electrical professionals can make informed decisions and apply the code effectively in a variety of situations. Furthermore, it's important to recognize that electrical codes and standards are not static. They evolve over time to incorporate new technologies, address emerging safety concerns, and reflect changes in industry best practices. Staying current with these updates is essential for electrical professionals to maintain their competence and ensure the safety of their work. One way to stay informed is to participate in continuing education programs offered by industry organizations, trade schools, and manufacturers. These programs provide valuable insights into the latest code changes, new products, and emerging trends in the electrical field. Another valuable resource is the National Fire Protection Association, or NFPA, which publishes the NEC and other electrical standards. The NFPA offers a variety of training materials, online resources, and certification programs to help electrical professionals stay up to date with the latest codes and standards. In addition to formal training and education, it's also important to cultivate a culture of continuous learning and improvement within your organization. Encourage employees to share their knowledge, attend industry events, and participate in code discussions. By fostering a collaborative learning environment, you can ensure that everyone is aware of the latest code requirements and best practices. Furthermore, remember that the NEC is not just a set of rules to be followed, but a comprehensive guide for ensuring the safe and efficient operation of electrical systems. It's important to understand the underlying principles of electrical safety and to apply the code in a way that protects people and property from electrical hazards. This requires a thorough understanding of electrical theory, wiring methods, and equipment installation practices. Finally, always remember that electrical work can be dangerous, and it's important to take precautions to protect yourself and others from electrical hazards. This includes wearing appropriate personal protective equipment, following lockout/tagout procedures, and verifying that circuits are de-energized before working on them. By following these safety precautions, you can minimize the risk of electrical shock, burns, and other injuries. Therefore, remember that the 25% adder from Table 430.252 serves as one element of a larger tapestry and a vital component in ensuring electrical safety and proper system operation. It is crucial to understand and apply the principles, stay updated with code changes, and prioritize safety in all electrical work.